Hi there, and welcome to Ades Workshop, and this is going to be episode 9 of the Knurling tool project. Now in this episode it's mostly turning, making up the various pins, screws, bits and bobs, dowels, that sort of thing that are going to go along with the knurling tool. So there is a little bit of milling, a little bit of design change, a little bit of cunning planning as I go along, so to speak, but then that's normal for me. As you all know by now, I make it up as I go along. Work so far, and then when you come across a problem, find a way to cross that hurdle, as it were, and then carry on. So anyway, we'll get straight on with all these bits and bobs. So you've seen me setting things up on the centre rotation many times now in this series. So yeah, I'm going to put an M6 tapped hole in the appropriate place in the block. That's 30mm from my outer edge. And I actually put a 9mm on the pins with a head on them, at whatever height they've got to be. So I'm drilling the hole 4.6 back from the sliding face, just to allow a little bit of clearance. So yeah, it's the usual thing, drill and tap a hole, M6. So I've set the main block up on centre height using the sticky pin. I'm sure you're sick of the sight of that by now. So I know that the centre of the block, or between the centres of the two pivot points, is at the centre height of the lathe. So to make up the little keep pin to go on the top, to set it so I can drop it into depth every time. I mean, it's not critical because it will self-centre to a certain degree. Let's just have a look. 6.95, I think we'll call that 7mm. So I need a shouldered pin with a head on it, 7mm to the shoulder with a 6mm thread that'll pick up on the top of my tool post, and every time I drop it in, it'll just drop onto the head, and I know it's at centre height. So we'll get on and make that pin. As you can see, when I've made these little stop pins previously, I've made them out of steel. I think they were silver steel I made them out of, and I've chemical blued them, or blackened them, cold blacked them, the same as I've done with the blocks. Now I do intend on doing the same, the cold blue, on this, and I thought it would be a nice little contrast. We'll make one out of brass for a change. So I did have a little slug of brass left over from when I made the barrel nut. This is a bit that was in the collet when I made the barrel nut, so either that or the little half nut, I can't remember which. So I thought, yeah, I've got this slug end, so I'll make one out of brass. Okay, so this shouldn't take long, and I think we'll make one out of brass. I'm only holding on a little bit in the shot. I'll have to take it gently. I may put a tiny centre in the end of it, just to keep it safe. I'll be alright, as long as it don't go mad. Tell you what I'll do. I'll just go round and, yeah, we are tight. Just make sure the chuck's tight. I didn't want it jumping out on me. I didn't want to go tickling it at a rate where it's going to take me forever. So let's have a little look. What's the major diameter? 17.5. I think that's 19mm, isn't it? 3/4. I'll take 1/2mm aside and then we'll have a measure. There we go. Just gently tipping over the surface here. I don't want to go crazy on it. Let's have a measure of that. So I'm looking for 17.5. Let me just bring you so you can see where I am. 17.85. Take 0.15 aside. And that should be the head diameter. Might take a tiny bit more. 17.5-ish, that's close enough. I'll just give myself a 0. Right, I'm looking for about 8mm thread, and I want a 7mm shoulder. So I'll have 10mm of thread and a 7mm shoulder. So I need to turn back at 8mm diameter, 17 back. So there's my 0. I'm going to stop about 16.5 back and face the underside of the head afterwards. It's 16.5. I think I need to take that major diameter back a bit further. I just went back to the 0. There we go. Right. Carry on. So 17.5, and I want 9. That's 8.5. So if I say 4mm aside on the DRO, and we'll have a measure. 16.5. That's 2mm aside on the DRO. Again, I could probably have taken like 3mm off in one cut, but I'm not holding it that well in the cut. There's a mill cut. Again, I'm hand feeding this. I haven't reconnected the feed wheel or the banjo in the back of the headstock. There you go. So there's the 4mm. Theoretically, that should be 9.5 diameter. Let's have a measure. 9.4. Okay. 9.38, but not fussy. 0.2 aside. And this should be the finishing cut with that diameter. Should have sped it up before I started the cut, really. Okay, I'm going to give myself a 0 there. And I'm going to face this to the 17. Back a bit. 17. Right now to the 0 on the DRO. Okay. So that being 9 diameter, I want 6 for the 6mm thread. Or just under. So 1.5mm aside over 10. Again, I'll stop at 9.5. That's 1mm aside. I went to, this was good 10. my eyes, but that looks bigger than 6. Oh, 6 on the nail. I'd normally just nip about 0.1 off the top of that to run a die down it, but because it's brass, it will cut no problem. So I'm going to put a tiny undercut, maybe over 1 mil on the bottom, by 1/2 mil aside. So I'll come to my 10, my shoulder length of 10. I'm going to wind in, to a mark of 2, that's 1/2 mil aside, so that should measure 5. And just put a little undercut in there. Okay. So let's have a few chamfers, shall we? What did I do with the chamfering tool? There it is, there it is. Everything to hand, except for when it isn't. We'll have a nice lead in on there. Get the die started. And I think just a break edge here. And we can have a chamfer on the underside of that head. Okay. And now, that's the pin all done. Ready to accept the thread. So I've got my winding handle in the back of the headstock. Just give the die a pull to get it started. Just break the threads a little and wind the die into the shoulder. There we are. M6 on there. Okay, so that's that side done. I'll just flick it round the other way. Hold it gently on there. I'm going to remove all that excess material now. Just get the tools at the ready. You just make sure you can see. Bear with me. Yes, you're all in shot. And that looks okay. I'm just going to remove all this lot. We'll do a bit of a cosmetic job on the top of this, I think. Don't want the head too thick. As you can see, this doesn't take very long at all. Okay, and another throw. Got rid of the unmachined bit. That's probably too thick for me there still. Tiny bit more. Again, it's one of those ones. Have a look at it. If it looks nice, chances are it is. If I can put a bit of a chamfer on there without hitting the jaws. That's not going to be enough. Let's put my 45-degree tool up. I can get at it a bit better with that. So I'm going to sort of blend a big chamfer on the outside edge, and then I'll dress it up. Okay, we'll call that the first hit. Angle around a bit more. Don't know whether it's in shot. I've probably lost you on shot here. See if I can give you a better position. That's better. At least you're you can see them, the part at least. So yeah, I put that first chamfer on. There's another one somewhere in the middle of that. set this just off square, am I? Can't quite see. No. Okay. So there's the part screwed into place. To tighten it up, I'm going to want a couple of flats on either side. You can see I did something similar on the previous one. So if I get myself a piece of card, something like that, it's 17.5 head. Let's say, let's have a look. 14mm spanner. Yeah. I've nipped it down into position, so a couple of flats at 90 degrees. That's 3.5mm divided by 2 is what? That's 1.75. So 17.5 less 1.75 is 15 and 3/4. 15.75. So if I file a flat on there until I get to 15.75, then go the other side and file a flat on until the 14mm spanner fits. So I'll get on with that. Well, there we are, we're on a winner. 14mm spanner fits, and get rid of the, and that will lock it on centre height. Okay, and obviously I'll just Loctite that in at a later date. So I found a length of 10mm silver steel bar, and I've just made up a little pin, or well, it will be a little pin. Now I've got a diameter of 6.35 over 17.5, and I've got a head on the top which is sort of 8.3. I mean it's 2mm bigger, nearest damn it, in what's it. My idea being that I am going to put a slot in the one side of this that the head will drop into by 2mm deep, or 2.5mm deep slot, and it's going to be a 2mm head, and that will allow this pin to just about come to the other side when it fits. Now, as it stands at the moment, those just, well, they don't go on, they nearly go on. It's going to need a polish at some stage. They're measuring 6.35, so as they stand at the moment, they won't go into those holes because I've got 6.3 in the holes. I can play with those at a later date. So what I'm going to do is get my parting tool up now, chop them off with a 2mm thick head, or maybe 2.5mm thick, turn them round, machine it to 2mm, and then I'm going to put a pair of flats on the head. So that when I cut a slot, let me just get a Sharpie, when I cut a slot in here, in the outer face, well, in fact that's the bottom one, so yes, it is going to be in this face, a slot dead level with the outside of the hole, the head will drop into that 2mm deep slot, or 2.5mm deep slot, and stop the pin from rotating. Now the idea being that I want the pin to be static in this block and not rotate, and that any rotating will be the knurling wheel on this pin, and if this pin wears, it's a quick simple replacement to make a new pin, whereas to make a whole new block, you know, if the pin rotates in the block, is going to take time to do. So I'm thinking about the longevity of the unit, so to speak. But yeah, a quick little pin is easy to make with a couple of flats and a head on it, whereas a whole new one of these blocks, you know, takes time. So I'm going to chop that off, maybe 2.5mm back, face the back a bit, little chamfer, and then I'm going to file 2 flats on it. Now I am planning, as these are silver steel or O1 steel, on heat treating them. I'm going to harden them, and then I'm going to temper them back, but that's at a later stage. Well, that will allow me time. You know, when once I've tempered them back, I will be able to polish the final diameter that's needed to get a nice. You know, it wants to be a nice fit on this wheel, and I want it to be able to fit through the 2 dowel holes as well. So once it's down in place with its flats on the head, I'll have to look at some sort of maybe little keep plate of some description, just to hold the pins in so that they won't rotate and they're fixed in position. But that's further along the line. So anyway, yeah, that was simple turning. Getting the 6.35. Let me just actually put the lid back on my Sharpie. Yeah, I've got a diameter there. Yeah, maybe it's a tad over 6.35, but that'll come out in the polish. I'm just finishing these heads to thickness now. And one more scratch. Speed it up a bit. There we go. That's 2 mil thick. Change the tool over for a chamfering tool again. And let's put a little break edge on it. Okay. So other than putting the flats on the heads, that's the 2 pins done. I think I'll file the flats on, then I'll heat treat them, then I'll polish them back up to fit as we're doing the later job. So having finished machining the little pins, as you can see, I filed the flats on the sides of them down until we just touch on the body diameter. So my next process is going to be to mill the slots in the side of the fingers that are going to take these little heads so they recess to stop them turning.